Okay. So yeah, what our topic today is serial LEDs in mostly in pinball. So it's how we can use them, how they work, what's on the market, how to control them, how they work internally, how they work in the Mission Pinball Framework, and along the lines I will give some recommendations what to do and also what not to do in some cases. So that's our agenda for today. First, how do lights in pinball typically work? That's what most of you probably know, but newcomers might not. So we will go over that for a short minute. Then we talk about serial LED controllers, like the hardware you need to interface those LEDs, and which chips are on the market, and what are the key differences, what is common, what is not so common. Afterwards, we go into wiring, it's serial LEDs, so you have to chain them, but I will show you how that works. And then we talk about the data format. It's a little bit more technical, but it's needed to understand some of the things which are going on. And at the end, we got a demo, and we can play a little bit with our setup here, and I can show a lot of stuff. I even got a separate agenda just for the demo because there's so much to show, and otherwise I would forget. So let's go into it. So typically there are like on traditional machines, lights in pinball have been incandescent bulbs, and they usually work in a matrix. So you got rows and columns, and then you got like one driver which drives the rows and one drives the columns. So this goes up, down, and same time all the lights which should be on are then on in the columns, and then the circuit is between plus and minus, so negative, positive, and then it's connected or it's closed, and the light will light up. That's how it's traditionally done to save wiring and mostly to save wiring. And then there are also sometimes lights which are on a driver, so like a coil, like a traditional like pop bumper, for example. It's directly on a driver on a transistor. That's mostly done for flashers because they need more voltage and more current, and sometimes also for other stuff like GIs. GIs are typically also on a single driver which just turns them all on or off. And additionally, there's like on newer machines, there's like parallel LEDs where you put one central controller and then fan out to every LED. So that's like a star topology, which is usually a lot of wires, but it's a very robust setup, right? Because if one LED fails, just as one LED fails. And then there's like serial LED, that's what we're talking about, where you got like chains of lights. That's very efficient on wiring. So one LED connects to the next one and so on. Disadvantages: if one LED in the chain fails, there's a high chance that all the LEDs after the LED also fail. And that's basically the trade-off here. So that's like serial LED is a lot cheaper in general, but you have to take some steps to make it reliable. Nevertheless, it's actually done in modern pinballs, like Wizard of Oz. Probably most people know, was the first machine doing it, and modern Sterns all got parallel LEDs. We also can talk about how that works. It's a little bit different than the stuff we do here, but similar in general. So yeah, what are your options for if you want to do that in your machine? What are your options? So there are like, I would say 3 or now 4 options which you could really use. The first is like, it's the Fadecandy. It's from Adafruit. It's like, I think $25 roughly. It's like it's a teensy controller technically. It looks like this. It's a small board, and it can drive 8 serial chains, they call it, and it connects to I think it's mini USB. and it's a very cheap board, quite reliable, and it works well. I got my setup on that at the moment, but it would also work on other controllers. So another option is the PD-LED board from Multimorphic. They got the P3ROC controller, and that can interface to multiple PD-LED boards. That looks like this. So it's like it normally drives parallel LEDs. Like all of those are, I think, 84 parallel LEDs, but it can also run like 3 serial chains in advance, in addition, basically. So then you only got like, I don't know, 70 parallel LEDs and three serial chains. That's that's this board. This is a prototype. That's why it has this nice sticker, which they sent me when I added MPF support for it. And then there's like the fast Nano controller. That's basically their, let's say, main CPU that interfaces all the node boards. And there are like 4 chains for serial LEDs on here. And yeah, that also works. It's, I think, 250 something bucks. The PD-LED, I don't know what it is, but it's something in a similar range, I guess. And then there's also like the Open Pinball project with the new CPU that also got like serial LEDs with all the stuff you want. So the old Open Pinball project also had serial LEDs, but that was a little bit limited. But the new one is really great. And there's more, like there's a lot more, like Stern Spike and some other boards also got serial LEDs, but those are the most common in homebrew, I would say. So what chips are there? So there's actually a lot of chips. Just wanted to check the chat. So like there are a lot of chips. So the most common chip is WS2811 and WS2812. So those are the most common chips. The difference is like the 11 version is actually a chip. It looks like one of those, so a really small one. I can show you all the stuff later also on the other camera in large. But it's a small chip with like 8 legs, and the 12 version is basically like it's an LED which contains the chip. So that's basically all in one. That's basically the invention on the 12th version. So, but technically they are similar. Then there are more exotic stuff like WS2814 and SK6812. That's like basically a knockoff chip somehow, but it has the same protocol, and it's usually used for RGBW. So that's like an RGB LED with an additional white LED that just gives you nicer colors, especially if you turn them white, because it's then not a mixed color. It's actually a pure white. There are also versions with just white, or also like some purple or orange. There are different options. Like there's a lot of options there, which is sometimes hard to guess, but they also work, and they're technically the same as the two above. Then there's like WS2813 that has actually a redundant data line, so that if one LED in the chain fails, then it basically can skip one LED, and that's super nice for redundancy reasons. But it's also one additional wire, so we will see that later. So it's 4 instead of 3 wires, and then there's like the same for the WS2815. It's relatively new, and it's super cool because it runs on 12 volts. Because like on those 5 volt LEDs, if your chains become very, very long, you sometimes get issues that the voltage drops too much in the chain, so you need to add more points to feed power into it. And that should be much better with 12 volts. Also, you need thinner. You can use thinner cables and so on. It's super nice, and it also has this redundant data line if you want. You you can just omit it if you do not want to use it. But it's there, so that's exciting. It's relatively new, maybe a year, and there's not much on the market yet, but those exist. So they also work with the same controller. So all those 4 work with the same controllers. It's the same protocol, but just different physical stuff, physical options, right? Like voltage or data lanes. And then there is APA 102. This is like, this was basically a chip from another manufacturer to make it more like robust. So they added an explicit data line. So explicit clock line, which is like you can run it at slower clock speeds in your CPU and so on. I don't know, it probably never really I guess it's more expensive, and so it probably wasn't really used, so I didn't see much of those, but maybe they exist somewhere. They got one cool feature, which is basically they got 5 bits for a global brightness. So practically that means that they got more like shades, like more color shades. Because if you, for example, want to dim your machine to 50% brightness, you set the global brightness to 50%, and then everything is automatically multiplied by 0.5. So that's super cool. But I've never seen those, and I don't have any. It's also, they require different controllers. And then quite also popular is like LPD880X, so it's like X for 3 or 6. So it's either 3 channels or 6. I've mostly seen the 88003. They can run with up to 12 volts. It's also cool. And they also got an additional clock line. So they got four wires, but so they should be more robust in general. I don't have any, but they also work on this multimorphic board as far as I know. And I got a different board which also supports those. And those are like the, in my opinion, the most common chips which are on the market. So let's see how this works in general. So in MPF, we got like the MPF PC that's on the left, and then it usually interfaces some controller, one of those I just showed you, or some other controller. So there's more on the market. And that's usually via USB. And then those controllers got like multiple chains. So they send out like a serial bit stream. So they actually send bits and bytes out, and that represent the colors of the multiple LEDs connected. So sends it to the first LED forwards the data to the second LED, and so on. Then there's usually some kind of clock signal or some pause or something when the LEDs know that, you sent like 10 color values, they all shifted into the LEDs, and when this clock happens, then they display the color they just got. And this happens in multiple chains usually, in parallel basically. So that's it's generally a good idea to run like multiple chains just for redundancy reasons. So one LED fails, just this one chain fails. It's also better for like power distribution reasons, because like otherwise you need really thick wires, because like the power has to go through all the LEDs to the last one, right? So you want to keep them powered. So in my opinion, like 30 LEDs roughly per chain is a good idea. Maybe you can do 60, but you don't want like 500 in a chain. That's usually not a good idea. So how do you wire this physically? That's how this typically looks. So again, on left the PC, which interfaces the controller, and the controller then sends the serial signal. And additionally, you feed power from some power supply unit, like a 5 volt or 12 volt switching power supply, which needs to be strong enough, right? So you could expect for like each RGB LED is like 60 milliamps per LED. So if you've got 100 LEDs, it's like 6 amps already, right? And that's not something your small supply usually handles. Like I got a cheap one, and mine has like 6 amps max, right? So I could drive 100 LEDs, but I normally use that for logic power. So it's fine for my small setup here, but it's probably not enough for a large pinball machine. So you should account for that. You should also think about like the voltage. So those standard LEDs with those 5-volt LEDs run between 4.5 and 5.5 volts. And if you run high currents, and you typically lose voltage drops between the power supply unit and your first LED already. So it's sometimes a good idea to dial it a little bit higher. So run it at like 5.5 volts or 5 to 3 volts or something, if that's possible. But a lot of supply units can do that. And that will help you that you at least got 4.5 volts at the end of the chain. Because in my experience, one of the main reasons for unstable chains is that you actually drop below 4.5 volts in those chains. Those LEDs still work up to like 3.5 volts, but then like the blue looks weird. They sometimes start flashing and so on. So just measure that your chain, in the worst point, like at the end or in the middle of the chain, you still got the minimum voltage, even when they're all at full brightness, right? That's something I highly recommend. So now, like for the more technical part, that's important to understand. Is like we got the serial like bit stream, right? So how does that work? And the answer is like it depends. So consider we got like 3 LEDs here, a chain of 3 LEDs only. And now the easiest way would be like to send just the colors, so like red, green, blue, red, green, blue, red, green, blue, and then like a clock or some pause signal, so that they know that it's now in the right position and they should display this color. So that's actually how this works with WS2811. So they actually use that exact bit stream information, or this color order also. So additionally, for other LEDs, we can also have this pattern, right? It's like green, red, blue, green, red, blue, green, red, blue. That's what we got with WS2812. So those chips are that basically they swapped green and red. I don't know why they did that, but that's actually how this actually in those chips for some reason. I don't know. And then there's like the more exotic stuff like like RGBW LEDs, right? So they got like an additional white channel. So how does that work? So that actually works this way. So like we send red, green, blue, white, red, green, blue, white. So now like if we look at it, that looks shifted, right? So the white is in the position for the second LED, and that's right. So basically I put borders around it. That's actually where the LEDs are. At least if you go with a standard like LED counting, and that's what most controllers do. That's really important to understand that LED 1 on the left is often number 1 on the controller, or often 0 index, so 0, 1, 2. So that's basically the first index, and then the second LED, the third LED. And in reality, it's like index 1 and index 4, like this. The red for the second LED is index 4. It's not actually 2, it's 4. And for the RGBW LEDs, it's like then index 5. So that's something which MPF calls channels. So the stuff below is like channels. That's the channel number. And the stuff above is the number, the light number. So you see those both exposed in configuration, and you can also configure both. And MPF then calculates the correct number. But I will show you how this works later. So yeah, keep that in mind. This is basically what I plan to do for the demo. I will show you the different different LEDs I got, WS2811 11 and 12, and I got a few of those. I got the RGBW one model. I got a few controllers which we can look at. I got some lenses from China for those LEDs. I can show you those. They are pretty neat. You can do all crazy stuff with it. We can look at cabling. So how do you cable it? And at the end, if there's time and if you want, we can look at custom board designs, how that's done. I fabbed 2 boards in China, and I can show you how I did that and how the design process works. So that's the agenda for today. If you do not have any questions, then I would just start with that. So let's see. Let me show my setup here. So that's my setup. We can also show it full a little bit better, right? So okay. So let's start. So what do we have? We got like different types. The first type is those. Those are basically Christmas. We call them usually Christmas lights because, I mean, you know those from your Christmas trees. They are just connected similar to this candles on your Christmas tree, and that's why they got their names. They are pretty cheap, like 15 bucks from China or Amazon, and often they come with like some rubber around here. I cut it off here so that you can see what's inside. So here's basically, it's the chip in there. It's a WS2811. You see this arrow, so the in signal goes in here and out there. So that's out of on this side, in on this side. That's how they look. We can basically turn them on to yellow, to red, or green, or blue, or white, purple, and off again. So those are the Christmas times. Then I got something special. So, I mean, you see those chips in here, and those are the controller chips. You can also buy those controller chips. So what I did is like I got those sheets from China, and that's like a lot of those chips, and they are only like, I don't know, 10 bucks for 100 of them. So that's really cheap, and you can, I mean, if you look close, here you connect like the inputs and outputs, so on both sides, and on top there are like 3 LEDs to it, and you can put any LEDs on it. So like you can put white LEDs, you can put yellow, red, whatever LEDs. So that's super cool, and I actually did that. I actually connected like, can you see it? Not yet. So here, oh, so here you see one of those LEDs. I hope I didn't fry my Fadecandy. It works. That's good. So this is the chip, and I connected like 3 LEDs on this board here, and I soldered like a connector here, right? That's just an angled. This is just an angled connector, and that feeds to the Fadecandy over here, and it gets 5 volts power and connects to those LEDs. So now we can again turn on my LEDs. So now the red LED, right? It's just the first one, and then we can do the green LED, it's the second channel, and we can do the blue LED, the third channel. So yeah, we can put anything here. We could also put like only red LEDs, no problem. We can also put yeah, we can put orange LEDs, whatever. So that's super cool if you got like existing lights, for example, top lights on your pinball, right? So those are not parallel LEDs, they are serial, and they're not serial LEDs, they are parallel LEDs, and you can use this chip to control them, right? And that's really nice. And I also use that, or we use that in our machine for some LEDs, because it's just more flexible. You can basically connect anything, really anything. And we can also do like white, and now like it's a little bit bright, right? But you can see that all three are now on, right? So it's a little bit hard to see. So hi Sean. So the question is like, is EM noise an issue for serious setups? In my experience, no. Some people had like issues when you put it around speakers, for example. That might be an issue. But in my experience, like there are like two things you have to do. First is run separate grounds. So really do it. Like run separate ground from the power supply unit to your LEDs and run them separate from your high voltage. If you share ground with high voltage, I mean, connect them at the power supply unit. That's important. But do not share the line between the power supply unit and the LEDs and the coils. If you do that, that will lead to issues. And make sure that that the voltage is high enough. So if the voltage really drops below this magical like 4.5 volts, then we've seen a lot of issues. Like it started flickering sometimes. But within our machine, once we had the voltage controlled, everything was stable at full brightness. Like now it's all on. Now at full brightness, we had no issues whatsoever. So it never failed. I mean, we had some LEDs which failed, but they failed basically at the beginning. So we connected them, they failed, or like maybe 5 minutes. So they initially failed. But all that survived that never failed, and they never flickered. Except maybe if you had dead solders and stuff, right? That always has issues. So earlier on this thingy here, on this ring, I connected it, it turned on once, and afterwards it didn't. And then I found out that like actually the solder has been dead, or like it was a bad solder. I renewed it and now it's working perfectly. So yes, those chips fail sometimes, but we didn't have issues in our pinball machine. So like we got like 500 LEDs roughly, 500 RGBs, so 1500 total, and we didn't have any issues whatsoever there. So that worked for us, at least. I know that, for example, Coleman had some issues with like his speaker Basel, where they started flickering when they became too close to the speaker. But other than that, I don't have any hard evidence where this happened to people. Hope that answers it. So yeah, let's go on what we got. So now I got like the W812. So like the 11s are like all those chips, right? So the 11s are always the chip. So that's like the RGB order, right? Because I mean, you can solder them in any order, and so they're usually RGB. And then there are those chips. I can show you one close. That's basically how these chips look. Doesn't focus so well, but you get the idea. It's like a 50/50 chip, how the package is called. So it's rather small, and those are very common and very cheap. So like roughly 10 cents, I guess. At least what I saw, they are roughly 10 cents in China. So let's start with like something. Let's turn. No, let's keep white. So the first one I got is like the fast LEDs. Those are those small thingies here. So those are used for. I got a separate one somewhere here. And they are used for inserts. So like that's how they look from close. Maybe I should turn off the LEDs. Better. So that's how they look. okay, it failed again. That's the thing with the solder joint. Sometimes it turns off after a few tries, but no, it doesn't want to turn off. But now let's go for a mechanical solution. So this is basically how this fast insert looks. So you can basically screw them. Let's make a screw hole. You can just screw them below an insert, and then they light up to the top. So that's super simple. They're roughly like $1 per piece, and you can get them on sheets. They look like this. So you get a sheet of 50, and then like I did here, you just solder like those connectors here. I think they're also available in pre-soldered, but I like to solder those headers. It's a nice activity. You get something done, and it's and you do not have to think. So it's super nice. Yeah, then break them apart, and they work pretty well for us. So we use them in a lot of inserts, like probably 100 or something in our machine. Initially got 150 or so. And yeah, I mean, we can turn them on again. So like that's how they look. Next is like custom inserts. So for some inserts, like an arrow, so like this thing here, that's a custom board I produced in China for arrows. So we got like arrow inserts, and I wanted to have it like running, so that the insert is running like this. And you can look up my YouTube video of our machine, and you will see that. It's a nice indicator to see that you should like shoot this up in this direction. In my opinion, it's a nice touch, and it's also a little bit brighter than a single one, so that's why we did that. And then we got like this one. That's a circle, obviously. So this is basically those big round, I think 1.5 inch inserts. And yeah, we produced a few of those. So this is basically how this looks when you get it from China. You can take it out. So I had it produced and populated in China for a few bucks. It hasn't been very expensive. And you can see that actually I did the arrow first, and this is still named arrow insert, even if it's a circle. But that's how we did that. And you can screw it down. And I think we used like 4 of them in our machine. And I got some spares here. So that's how they look. I can also show you the arrow insert. That's like looks like this from the back and this from the front. There's like a small capacitor next to the light. That's what you're supposed to do. Some cheap Chinese stuff leaves that off, but it's less than a cent. So if you design it, put it on there. And then next we got the Adafruit bars. That's like this here. In our machine, we use them as live bars. So because we got a head-to-head machine, and you fight the other player, you got your lives on your slingshot, and we use those on the slingshots. And I got some more of those. Here, I used them to blind this stuff. It failed apparently. So that's how they look. I think that's still closed. And yeah, I mean you can connect them, but for here I just soldered connectors on it so that I can interface them with all the other boards. So all those are like basically one chain here, right? So this is one chain here. The crystal lines is one chain. The RGBW is a chain, and this one is also one chain. And the chip I showed you in the beginning is also a separate chain. So I got like 5 chains here. Yeah, that's something which is available from Adafruit. Like a lot of those stuff, it's called as NeoPixels at Adafruit, and they got a lot of those LEDs. But you can also get them from AliExpress or elsewhere, a little bit cheaper usually. But the Adafruit stuff is well designed, and it generally works really well. just check if it has the proper mounting holes. Sometimes the PCBs from Adafruit are like, they're just the LEDs and there are no mounting holes, so it's a problem sometimes to mount them below your playfield. Yeah, then there's like this strips, which I got on the side now. Let me see if I can just, that's bad. I wanted to put away. Yeah, now you can see them. This is basically strips which you can get on a reel. So like usually you get, I think, 3 meters or something, or 2 meters or 5, a different length, and they are flexible, so you can twist them even. I just yeah, glued them down a little bit, otherwise they would move away here. They work the same chips, just flexible, so they can also do all the colors, and they work as you would expect. And basically, you just solder the connector here, so they do not bring connectors. And at the end, on the other end, you can solder the next LED to it. Yeah, that's basically for the WS2812 stuff. And now I wanted to show you this, which now failed again. So it failed earlier. It doesn't accept my commands anymore for some reason. Before that happened because of this connector. I don't know. It's also some basically undocumented LED. I have no idea what it is. That's what Adafruit put on there. It's from Adafruit. I bought it just to play with RGBW LEDs. We never actually used it, but those rings are also available with other LEDs. So super bright. I don't see anything anymore. So I won't. That's it. Now it's white and it stays that way apparently. Hard to convince it otherwise. So it might also be a thermal issue on the chip. So this sometimes the inputs fail. So maybe the first input failed on this one, and then all sequential LEDs also fail. Yeah, now I can show you like the controllers again. So my Fadecandy is like over here. That's the Fadecandy. It's super small. There's USB, and there's all the connectors here, which is now a little bit messy here on my setup. So in our machine, what we did is like we designed this board, which lives below the playfield, and it has like high voltage here, and this is basically 5 volts input, so with like 2 5 volts, 2 grounds, and because you need a lot of amps, so you typically need like at least 10 amps for a playfield, and then we feed like 5 volts here and the serial chains here, and below that here there's another Fadecandy, which then feeds those 8 connectors here. Also got some small capacitors here to smooth the voltage, and we got RG45 connectors to connect the bus, basically to connect the bus from the controller to the node boards, so that we can separate or remove the playfields from the machine with just removing RG45. There's also a board we fabbed in China, inexpensive board, and yeah, high voltage part, low voltage part, some indicator LEDs so that you can see if voltage is on. And yeah, we use that a lot. I think like five ones in the machine, one for the topper and or for the back box, and one for each playfield. Yeah, I showed you earlier the PD-LED, which works with the P3 rock. It's more for parallel LEDs, but it can also do serial LEDs. And the fast Nano again, that's basically how that looks. Also a nice board. So that's basically what we got on controllers, and now we also got like lenses. So what are lenses? Lenses look like, let me show you. This is, for example, this is a lens, and this is useful if you, for example, want a spotlight. And those, they fit like those 50/50 LEDs. And now you got like a larger LED. So we use those as basically spotlights for above the playfield. We use this with this LED. So this is basically a single LED on a single board from Adafruit. I mean, as you can see, no mounting hole whatsoever. So we 3D printed like a mount for it. And then, this, if you look closely, you can see that this is actually, this LED looks yellow. And the reason for that is, I mean, the others, they look like different, right? So if you look at, you see them side by side, those are like more white and this one is yellow. So this is actually an LED with 3 white channels in it. So you can buy those. And we use this as spot on top of the playfield. So that is how this looks. Then we got some printed part below it or behind it, so that you got a decent spot. So this is one of the lenses we got. Other lenses are smaller. We try to put them below inserts so that you do not see the LED. Sometimes you see you see a point where the LED is. You even see that on like commercial machines at Stern, but I mean, if you're building a machine, you want to do everything better, so we try to improve that also. And you can buy those lenses also from China for basically less than a cent per piece, and with different angles. So there's like 30 degrees, 60, 50, and yeah, they differ slightly, but not much in reality. And we did some tests with some testers, and nobody really had a preference for one or the other, so we left them off at the end. So what we can, for example, put one here, put it on this LED, and then you can have this wonderful experience of a lens. Put it on. You can see, I mean, it's a little bit larger. It's always hard to see with the camera, but it's like, it's now more to the top. So from my perspective, the light isn't really, I mean, it's not off, but it's not as bright as the others. So it focuses the energy more to the top, for example. So yeah, that's basically lenses. We can try the others, but they look similar to this one. So that's like 60-degree angle. And there's like this one that's, I don't know, what does it say? What's it say? 60? No idea. And it also looks, at least on the camera, it looks very similar. And then we got like a third one, which is flatter. And that's listed as 40 degree. But as you can see from top, it's not much of a difference in my opinion. So I know some people use them, but we decided not to. Because yeah, didn't make such a difference. But they work and they are inexpensive also. So yeah, what's left? So you probably already saw that. How we do it is like how we cable those LEDs. And what we do is like we buy those servo cables. So you can buy those for RC servos in China. So like one is like 10 cents, 10 to 14 cents roughly. And you can get them in quantities of 10 or 50 or 100. And they are available like 30 centimeters like this one, or 20 like this, or also like 10. And probably also others, but they are really, I mean, they're really a easy and cheap solution to, I mean, yeah, to connect those, right? So if you look at like this LED with the connector here, you can then just add those or connect those here, and yeah, just make sure that you put black on ground, or at least put them in the same direction everywhere. Because if you connect those, if you invert the connector, those LEDs will instantly die. They will just be broken afterwards. So never ever connect them the wrong way. So this is nothing you could do like in a production machine, because it's not easy to make sure that nobody connects them incorrectly. So you would probably run different connectors in a production machine. But for homebrew, it's super simple and super practical, in my opinion. There are other options. So some people get like pre-crimped wires, just basically like the white wire in here, and then they get connectors, and then they just put in the wires into the connectors, which has the advantage that this is basically a 1x3 connector, right? And then they got like 2x3 connectors like this, which is like probably a little bit more stable then. But in my opinion, they never get loose, because those RC connectors are used for like all those wireless planes, wireless cars, and all this stuff. So they are pretty sturdy, so they do not come off easily, in my opinion. From my experience, never happened to us, at least. So I recommend those because they're cheap, and especially if you want to connect 500 LEDs, you would have to crimp like 6 crimps for every LED and put connectors on it. That's a lot of money and a lot of time. So this is a lot cheaper. So for homebrew, I totally recommend those. And yeah, that's already what I got on cabling. We also already got 1 hour filled. And yeah, I mean, if you got questions, feel free to ask. And what I would show next is basically how to configure them in MPF. So all of those LEDs which I just showed. And for that, let's go over here. So I added them all. So the first LED I got is like the standalone LED, which I showed in the beginning, which is just one controller with 3 LEDs connected. And in my case, it's RBG, so the order is like, it's messed up. It's like the GB is mixed because I connected it incorrectly, and then instead of fixing the hardware, I decided I will just change the channel order in MPF. And so how this works with Fadecandy is like, this is the chain number, and then this is the index of the light for the number syntax. And for the channel syntax is the same, but it's like multiplied, so the index is multiplied by 3. Yeah, maybe we can start with the Fadecandy server. So the Fadecandy server has a configuration which looks like this. It's a standalone server application which connects to this Fadecandy board over USB, and you start a server process which then sends the stuff to the hardware with good timings and everything. So it has a reasonable default. All you have to do is basically to tell it the serial number of your Fadecandy, and as you can see here, you can have multiple Fadecandies. And then there's like this configuration map for chain 0. I map the first 64 LEDs and then the next 64 to the chain 1 and so on, right? So I map them 64 LEDs. That's basically internal stuff to this channel. So basically, each channel on my Fadecandy here is basically a separate chain. You're not seeing it. So each channel here is like a separate chain. But I could also have like 1 chain over 3 of those connectors and so on. But we recommend it this way, and that's also how we document it. And then afterwards, you just start this Fadecandy server, and once it sees the USB device, it just magically works. So that's super nice. Yeah, and then just tell MPF to use the Fadecandy. That's just this one line in hardware. And afterwards, that's working. And now we can configure the LEDs. The first one is like this one I showed initially, and nothing much to see here. We could also put like RRR here. So right, then it would be like 3 red channels, and if I put it to green, it would be basically off, and if I put it to red, all the 3 channels would go on, or would turn on. Yeah, then they got this stripe. That's basically the flexible stripe, the strip, and that is basically on my chain 1. It's because it's WS2812. It's RGB, it's GRB, sorry, not RGB. So you have to set the type, and I give it a tag so I can address it later. So what you could do for the second LED of this one is like you could put the increment the number. So I could put number 11 here, right? So this could be also number 11, and the third could be number 12, right? But as I'm a lazy person, I can also let MPF do it. So MPF can calculate the number based on the previous one, and that has the advantage if you add something to the chain, then all the numbers will be correct again later, and as long as all the others stay in the same place. But I could, for example, add a new one in between here, and I do not have to update the numbers here manually because it's calculated by MPF on startup. And that's what I did for this 10 LEDs on this strip. I show you in a minute how you can do this without repeating or without copy and pasting that much. And then we got like this small chain with all those WS2812 LEDs. That's basically the custom inserts. The circle is 7 LEDs, same deal basically for those. Also RGB, I put in some tags, and then it goes on. Like the arrow is like 3 ones, the bar is 8 ones. Then there's like the fast inserts, they are also the same, it's all the same chip, so that works the same. Now the RGBW, which unfortunately failed again, that works a little bit different. Now we use the channel syntax here. The reason for that is that the Fadecandy expects lights to have like 3 channels, and this LEDs have 4 channels. So we just tell MPF the first channel is 3, 0. And then it calculates that this like G would be 3, 0, R would be the 3, 1, B would be 3, 2, and W would be 3, 4, right, internally. And so on. And because now that this gets messy if you do this manually, you certainly do not want to do that. But we do the same with the previous stuff, and we also tag this again, like 12 lights. And then for the Christmas lights, we could do the same here. So again, this is RGB because it's the 11 version of the chip. And now there's like, I think it's 50 LEDs, and I really didn't want to do them manually. So we got one thing in MPF, which is like light strips, which just has a typo in, I know, but we stick to our API, so we didn't want to break configurations from users, so it's still with a typo. And now we can see, well, make me 60 of those. They should all look the same, and basically this is a number template, 4 minus the number, start with 3 because I did the first 2 manually, and probably missed the second one, right? That's 0, 1, 3. Didn't notice, but probably off. Okay, let's fix it. And yeah, so we can now give it some tags also, and it is a template how to do it. So it will then do 60 LEDs, which I think I only have 50, but doesn't matter. The controller won't notice. And that's basically how I do this, how I configured all my lights here. So that took me like, I don't know, 20 minutes for all the lights I got here, which is like roughly, I don't know, 85 LEDs. And then I got my players here, my event players, which can then control the stuff, which is what happens if I press like 1, 2, 3. You can see it in my face that the color changes and it lights my room, and turns off again. So basically that's how it looks in software. Also got like if you put a message in the chat, it will change the standalone LED every time. It will cycle around based on a counter and test those commands which I showed earlier. And that's how the configuration works. Yeah, so do you have any questions? Then, I mean, feel free to ask. I hope that it's everything is still working fine, but it looks like, at least it pretends to work. Otherwise, I would go and show how we produce those lights in China. So I can show you basically for the arrow inserts. I got the PCB here, which I can show you on here again. So this is basically the PCB, how it looks when we produced it. I got a few which are not assembled, so you can see that this contains 6 of them, and we produced like 10 of this PCB, right? So we actually produced 60 inserts, and then we had a few of them, like this one, populated. I think we populated around 40 of them, so that's why we got a few spares. You do not want to solder those LEDs manually. Seriously, that's not fun. You can do it like for 1 or 2 or 5, but you certainly do not want to solder a few hundred. That's not fun. I mean, soldering those connectors is easy, and it's relatively expensive to have that done in China, so that's why we didn't do that. And basically the same for that one here. You see that there's more print on this one, more documentation. Then the time for documentation, that will help later. And I can show now so we used KeyCut for designing those boards. Let me change the size a little bit. Yeah. So that's basically for the circle insert. That's basically how you start. So you put all the components to your schematic here in the beginning, and that's basically the connector 2x3. So here you do not say which connector, it's just the connector, and then you put in like 5 volts and ground and like a signal in and a signal out. And now you can see that we put a lot of LEDs here, actually 7, and there's basically a package for that, or you can make your own package, which then has a capacitor here, and that's basically we can ground and 5 volts, but it should be close to the LED. And then you connect the input and you connect the output to the next LED. So that's basically chained through the board. And I don't know if you can here on this side you can actually see that a little bit. Not very good. You can't. But you can see on the PC in a minute. So basically that's how those are connected. So instead of cabling them, we cable them on the one board. And then you basically export this as a netlist. Netlist is how are the parts connected. You select the parts. You say, well, yeah, I want this LED in this certain package, which is, there's only one package for this LED. And you say which capacitor you want, which connectors you want. And then you get like the schematic, or then you build the schematic here. And this is how that looks. So this is the routed schematic. So you place your parts, those, and then afterwards you route you route it on 2 layers. Basically, you got the top layer and the bottom layer, and both of them contain copper. You can also have like 4 layers, but it's a lot more expensive. The easiest version is like usually 2 layers, top and bottom. which is red and green here. But as you can see, that's so simple that I only routed it on one side, and the other side is just pure power. And that it's really important that you have those huge planes here, planes, so that you got a power plane and a ground plane, and because those need to be cooled. Those LEDs, they emit heat and they need to be cooled, and that's usually done via this metal plates. You could remove them, right? So you could just electronically, they do not make sense, but if you remove them, this will overheat, so keep them there. Also, the capacitor should be close. That's why we put them next to the LED. Do not put them too close, because then those nice lenses I showed you won't fit on it anymore, because then the capacitor is in the way. So leave a little bit of space there. So now we can render it in 3D. Wonderful, right? And now you can also see, like, unfortunately it cannot render the parts here because it doesn't have a package for it. But you get the idea how this works, and we got nice print and the same bug the print bug I just showed you. And that's also something I would recommend, just document on the board what you put there. Otherwise, you always have to look it up, and that's just so much nicer if it's just on the board. And we also, we printed the insert itself onto the board so that you know where to place it on the playfield when you want to mount it. And you can see, we maximize ground everywhere. Afterwards, basically, you export this, and then you usually have, depending on your manufacturer, there are multiple manufacturers you could use. For example, Seed Studio or Jail PCB, I think they're called. There are few around which give you very decent prices. So I don't know, manufacturing such a board, depending on the quantities, between like, I don't know, $10 and $3 or something. Depends a little bit on where you do it, how you do it, how many you do. And usually you have got a certain size. For example, you can produce a board like that, or like this, 10 by 10 centimeters, and then you panelize it so that you put multiple boards onto one, because I mean it's basically free to put more than one on those. And then you often get 10 of those. Then you decide how many of them you want to populate. Usually you have to upload like a bill of material where it says, well, C2 here is a capacitor of this capacity, with this capacity on this size, and then they will populate it. It takes like 2-3 weeks something for them to do that, depending on if they have the part, if they have to acquire it. But for this stuff, it's standard parts. They certainly have it on stock, so they can start right away. And that's in a nutshell how you do those boards. It's not particularly hard, but every iteration takes like 4 weeks or 3-4 weeks until it reaches your house. So if you make a mistake, and it can be as simple as not connecting something, you have to wait another 4 weeks. So it's easy to wait like 3 months until it actually works. And you also spend like money on each iteration. So that's like, be careful, check everything 5 times before you send it, and then you get nice LEDs. And in our experience, they also always work. We don't know if they actually sold us like counterfeit LEDs or something, but they work fine. They are awesome. It's not that they're coming from a major manufacturer, so they are from World Semi, which is also a China manufacturer. So if you got a reputable like source, then they usually work fine. It's not an issue now, in my experience at least. And yeah, that's already all which I wanted to show you. I can go back to like my LEDs and turn them on again, but then I'm looking red here. Quinn, when using RGBW LEDs on hardware that only supports RGB, I guess that only software fading can be used. No, you can always use hardware fading because the hardware only fades like the channels. Usually the hardware in the documentation has this numbering, but internally, I mean, it just sends bytes. And for some hardware, it's like so we can just send multiples of 3. And if you want to, I mean, if you got 2 RGBW LEDs, it's like 8 channels in total. So MPF would send like a 9th channel, but if there's nothing connected, well, nothing happens, and it would also send 0 there, so it's off. And so we can also use the fade stuff. And what we cannot use in some controllers, like the Fadecandy, is like the following. We cannot use like white point and like not gamma. Gamma is fine, but the white point stuff, right? Because the white point stuff corrects like the red channel, the blue channel, the yellow channel, and if you shift them by 1, then it would correct the wrong channel. So if you want to use RGBW on the Fadecandy, for example, then do not use like the white point correction, because that, or at least put the same value for all colors, then it works. But not do not put different ones on there. But other than that, I do not see any limitations for hardware fade. Did I design those small green boards that no, those are from China, and they are like I would say $10 or something. They are really cheap. So like I got this. So they actually sent me those 2 panels, and I broke off like 5 of them, right, on one of them. So this is like 4 of them, and the one here. And this is 100 LEDs, and they were like at least below $15. So that's really cheap. And the reason for that is that those LEDs, those boards are actually the same which I used in those other way around, right? Like this. They are used in those Christmas lights. You cannot see it. So those Christmas lights use exactly the same board, and that's why they're cheap in China. So for the people building those Christmas lights, they buy those boards, and you can also buy them on AliExpress. So that's available. So there's theoretically also like a chip with like, I think it has 9 outputs or something, which is WS2811. But I tried to buy it, but I found references to it, but I never found a source where I can actually buy it. And this, just go search on AliExpress, maybe also on Amazon, but then it might also come from China, so it doesn't matter where you buy it. And those work really well. I mean, put some I would solder them, and then put some shrink tube around it, and just shrink it, because then they're basically gone, and maybe have the connector look out, or also solder the connector. I mean, it's like yeah. What is it? Is it like 10 cents? So if you lose one, they're worth things in the world. Yeah. So, any other questions? Anything you want to try? I mean, I guess I didn't look for it, but those chips should be also available in China for manufacturing. So if you want to run your own light boards with different LEDs, you could also use those chips on your design, I guess. I'm certain that they are available, so that you can then put like 3 random LEDs on it. I mean, those are probably not the nicest form factor to mount them below the playfield, right? I mean, if you want to just put an LED somewhere quickly, it's a super nice solution. But it might be nicer to just produce like a larger board, which has then like 10 connectors or something for LEDs, and put like 3 of those chips or 4 of those chips on it. That would also be an option. Also, I mean, you could run like those light boards below your playfield and put a few of those chips on it. Actually, what Stern does is also super nice. They run like shift registers, so they put like shift registers, logic shift, TTL logic shift registers onto the board, and then just run regular LEDs with like a transistor. It's a little bit more expensive what they do, but it's I mean, it's super low tech. It's like running an SPI and pushing out bits, and then have the LED connect there. It's quite flexible. So I can show you some, it's just chips. I mean, I got some shift registers laying around because I played with Stern stuff. It also works on, like on a Raspberry Pi. You can also drive all those LEDs in Raspberry Pi with an Arduino and so on. So it's not magical to drive those. It's relatively easy, I would say. Yeah, so unless you got more questions, all I can do is like turn on the lights to purple or white. And then that's all I wanted to show you. Thanks for joining. Thanks for listening. Thanks for asking questions. I hope you're having a great weekend. And yeah, I hope you got time to make some pinball. Have fun with, I mean, with friends is hard, at least physically, but have fun with friends online and build some pinball, play some pinball, hack some pinball, and maybe fix a, there are no bugs in MPF, but fix a bug in some software or submit a new feature to MPF, and just be great to each other and have a great time. And see you next time, hopefully.